Welcome to the video lecture on the resolution of forces in the two-dimensional space. I am Dr. Lilly Mercy, Assistant Professor from the School of Mechanical Engineering, Satyabama Institute of Science and Technology, deemed to be University, Chennai. Let's get into the contents of the presentation. First, we will see what is a force, the basic definition and the basic idea about it, followed by when there are many forces acting on a body in a two-dimensional space, how do we resolve it? Followed by the resultant force and finding out the angle of the resultant force. We will finish this lecture with an illustration also. Now let's get into the first definition. What is a force? Force can be defined as the push or pull on a particular object. The object will respond to the force when the magnitude of the force exceeds the basic internal energy or the weight of the object. Let us look at picture A. Force F1 is acting on a particular cylinder, positive direction of x axis. So, from that we can understand that when the cylinder is unable to take up the force or bear the force, it will move towards its right hand side. Let us look at the next picture B. In the next picture, force F2 is acting downwards on the object. Now, that will make the object to move downwards. So, from this we can understand that whenever a force acts in a particular direction, the object will move according to that direction. Let us look at the picture C. In picture C, force F3 is acting at an angular direction. It is neither in x nor in y, it is between x and y, or let me say it is in the first quadrant. Now, when it is pushing the cylinder is going to move along the dotted line which is shown in the figure, but the dotted line is across the third quadrant. So, this is what we call it as principle of transmissibility of forces. That is, when the force that is pushing on the first quadrant can be transferred to the third quadrant as a pulling force. So, the force is transferred across a straight line. Now, these three examples that we have seen in A, B and C, they are acting along one particular direction, either along horizontal or in vertical or in angular. Now, look at the picture D. In picture D, force F1, force F2 and force F3, whatever we have seen, all these forces, all the three forces put together, they are acting on the object simultaneously. Just like as you see in the game of a soccer, with the picture that you can see in the left hand side, many players, they push the ball with their legs. All the players are exerting the force on the ball, and finally the ball traces one particular direction and it moves. It may be the direction of player A, or might be player B or player C, or might be the net effect of all the three players put together. So, we can understand that when an object is subjected to many forces simultaneously, there will be a net effect of all the forces and it will not be following a particular force or a direction. So, that is what we are going to see when we have many forces, how we are going to resolve it. Now, let us look into the next slide. What is resolving of forces? In the picture, I can see a dog that is chained, and the chain is along the vertical direction, in the horizontal direction as well as in the inclined direction. The third picture, the inclined direction, is a normal way a dog is pulled by a chain. So, whenever an inclined force is acting, we can understand that it is a combinational force of both the horizontal and vertical forces. Just like you can see in the bottom picture, the angular force is a combination of both vertical and horizontal force. So, what we are trying to explain is that whenever a force is acting along in an angular direction, we can resolve it into a horizontal force and a vertical force. This is for our simplicity. We have only x direction and y direction, the two basic principal axes. So, when we have forces across every direction, for our simplicity we resolve it to x and y directions alone so that the computational parts gets easier. So, how do we resolve it? So, when you have an angular force, that force can be converted into two forces, one a horizontal force and one the vertical force to its corresponding principal axis along which the angle theta is acting. Let me say the force F, which is acting angular on the object, the chain which is held on to the dog, it is at an angle of theta with respect to x axis, and let me say the force is F1. Then my force can be resolved as F1 cos theta and F1 sin theta, whereas F1 cos theta represents to the force across the horizontal axis and F1 sin theta represents the force along the vertical axis. When we have forces across all the four quadrants, so how do we resolve it? So, we know that the left side of x axis is the negative side of x axis and right side of x axis is the positive direction of x axis. Similarly, the upper portion of the y axis is positive, lower portion of the y axis is negative. When there is a force in the first quadrant, let me say F1 as shown in the figure, which is acting at an angle of theta 1, then I can resolve it into two forces. I call it as F1H, which corresponds to force in the horizontal direction, and F1V, which corresponds to the force in the vertical direction. So, F1H is F1 cos theta 1 and F1V is equal to F1 sin theta 1. Now, the force is acting in the first quadrant. In the first quadrant, both the x and y are positive. So, therefore, my F1 cos theta 1 and F1 sin theta 1 both are positive. Now, come to the next illustration, force in the second quadrant. In the second quadrant, let me say a force F2, which is acting at an angle of theta 2 is applied. Now, please note in all these figures, all the theta 1, theta 2, theta 3 and theta 4, they are with respect to x axis. Now, the force F2 can be resolved into F2 cos theta 2 and F2 sin theta 2. As I said earlier, F2 cos theta 2 is along x axis and F2 sin theta 2 is along y axis. But F2 cos theta 2 is along the negative side of x axis. So, therefore, it is minus F2 cos theta 2, whereas F2 sin theta 2 is along the positive side of y axis. So, it is positive. Now, let us see the third one in the third quadrant, when you have a force in the third quadrant. In the third quadrant, again we can resolve it into F3 cos theta 3 and F3 sin theta 3. But we know that in the third quadrant, both the x and y are negative. So, therefore, it is minus F3 cos theta 3 and minus F3 sin theta 3. Similarly, to the fourth quadrant, where it is positive in x and negative in y. Note one particular thing in all these forces F1, F2, F3 and F4. We can see that all the forces are acting away from the center point. So, whenever we have a force that is acting towards the center point, so how do we do about it? In that case, as I told you earlier, the principle of transmissibility of forces, where the force can act when it is acting as a push in the first quadrant, can be transferred as a pull in the third quadrant. When it is acting as a push in the second quadrant, it can be transferred as a pull in the fourth quadrant. So, when we see the illustration, I will be explaining little more in detail. Now, to find out the resultant force. So, as we said earlier, our aim is to find out the resultant force, that is the net effect of all the forces that is acting on a particular object. Now, each and every force that is acting is being divided into horizontal component and vertical component. So, when there are 4 forces, as I showed you earlier, that means there are 4 horizontal components and 4 vertical components. Now, we will be adding all the horizontal components together and all the vertical components together. Now, F1 cos theta 1, F2 cos theta 2, F3 cos theta 3, F4 cos theta 4, all are summed up together. But you can note a negative sign in F2 and F3. The reason, as I said you earlier, F2 is on the negative side of the x axis and F3 is also in the third quadrant, which is in the negative side of x axis. So, that negative sign comes, whereas in F1 and F4 they lie in the positive side of x axis. Similarly, in sigma V, F3 and F4 are negative. The reason is that F3 and F4, the third force and the fourth force, they are lying in the negative side of y axis. Now, after we arrive till this point, we can understand the summation of sigma h and the summation of sigma v, that it will give us two different numerical values. It might be positive or negative. When the positivity and the negativity of these values will give us the idea as where the resultant force is lying, that is, in which quadrant the resultant force is lying. For example, if sigma h is positive and sigma v is negative, then in which quadrant is sigma h and sigma v positive and negative respectively? It is in the fourth quadrant. In the fourth quadrant, sigma h is positive and sigma v is negative. So, once we get the values, we can understand that the net resultant force or the direction in which the object is going to move is on the fourth quadrant. Now, to find out the magnitude of the resultant force, the formula is R is equal to root of sigma v square plus sigma h square. So, we have found out the sigma h and the sigma v values. See, we square it. So, obviously, if there is any negative value, that will become positive. Then you find out the square root, we get the value of the resultant. That is, resultant value means the magnitude of the force in which the object will move. That value we will be getting it in the value of resultant. Angle of the resultant force, tan alpha is equal to sigma v divided by sigma h, or else alpha is equal to tan inverse of sigma v by sigma h. So, we have found out the values of sigma v and sigma h. Once we substitute in that, please do not insert the negative sign into this formula. Negative sign or the positive sign is just to denote in which quadrant the force is lying. So, we can just insert it as positive so that we get the alpha value. The alpha value is nothing but the angle at which the resultant force is lying. We will just get into an illustration to give you a more understanding about this resolution of forces. Let us look at an example. Find the resultant and its location for the following system of forces acting on a body. The body is shown by a red dot. We have four forces acting on the body. 2 kilonewton, which is at an angle of 25 degrees, lying in the second quadrant. 5 kilonewton force with an angle of 60 degrees with a push force at the first quadrant. Then 3 kilonewton, the angle is not given, we have to find it out. And 2 kilonewton of force acting straight down. Now, how are we going to resolve this? First thing that we have to consider is, we have to convert all the pushing forces into pulling forces. That is, all the forces should act away from the center, away from the object. The next thing is, if there are any missing components like finding out the angle or finding out the force, we need to do that first. So, the first step is that the 5 kilonewton force, which is acting at an angle of 60 degrees in the first quadrant, is the pushing force. It is not a force which is acting away from the object, it is a force which is acting towards the object. So, through the principle of transmissibility, I am now transferring this force from the first quadrant to the third quadrant as shown in the figure. Now, this force is being transferred to the third quadrant of 5 kilonewton with an angle of 60 degrees. We will come to the next force of 3 kilonewton, which is in the fourth quadrant. The angle is not given, instead a small right angle triangle is drawn. The horizontal value is given as 2 and the vertical value is given as 1. From that small triangle, we can understand that it is a right angle triangle. The hypotenuse is unknown, the adjacent side and the opposite side values are given. Now, we want to find out the value of the angle. If we could find out the value of the angle as shown in the picture, then this angle can be correlated with the angle that it makes along with the x axis. So, tan theta is equal to opposite by adjacent. So, it is 1 by 2. So, theta is nothing but 26.56. So, 26.56 is the angle that it makes for the 3 kilonewton. Now, we have made all the forces as they are pulling away from the object and all the angles are known. Now, we will go into the part of resolution. Now, we are resolving all the forces. We will take all the forces one by one. The first force, which is in the second quadrant of 2 kilonewton, making an angle of 25 degrees. So, we know that it is 2 cos 25 and 2 sin 25. But because the 2 kilonewton force is in the second quadrant, which corresponds to the negative side of x axis, it is minus 2 cos 25, whereas it also corresponds to the positive side of y axis. So, it is plus 2 sin 25. Go to the next force, 2 kilonewton, which is acting straight downwards. Because it is acting straight down, it need not be resolved at all. It is a pure vertical force. There is no horizontal force involved. So, obviously, sigma h, that is the horizontal force, is 0 and vertical force is minus 2. The reason for minus is that it is on the negative side of y axis. We will come to the third force, 5 kilonewton in the third quadrant, making an angle of 60. We will resolve it into 5 cos 60, 5 sin 60, both are negative because it is in the third quadrant, which corresponds to the negative side of x and negative side of y. The fourth force of 3 kilonewton, making an angle of 26.56 in the fourth quadrant, that will be resolved into 3 cos 26.56 and 3 sin 26.56, where x will be in the positive and y will be in the negative. So, it is minus 3 sin 26.56. So, we have now resolved all the 4 forces into each into 2 components, horizontal and the vertical component. Now, we will go to the summation of these forces. Sigma h, sum up all the horizontal forces. Summing up all the horizontal forces, all these signs has to be kept intact, as we have said earlier, just add it up together. So, we get the answer as 1.5975 kilonewton. So, it is positive. So, we can understand that the resultant force is going to be in the positive direction of x axis. The positive direction of x axis corresponds to either first quadrant or the fourth quadrant. So, we are now sure that the force is going to act anywhere in the first or the fourth quadrant. To find out exactly at which quadrant it lies, we will go to find out sigma v. In sigma v, we add up all the vertical forces, that is all the sine components together, and we add it together. We get the answer as minus 6.825 kilonewton. Minus corresponds to the negative direction of y axis, which means that it should be, the force should be either in the third or in the fourth quadrant. So, already we said it is in the x is in the positive side and y is in the negative side. So, x is positive and y is negative only in the fourth quadrant. So, from this we can understand that the resultant force is going to lie in my fourth quadrant. Now, to find out the magnitude of resultant, root of sigma h square plus sigma v square. So, the values that I have got, 1.5975 the whole square plus minus 6.825 the whole square, the minus will go off when we square it. Then we find out the square root of it, we get the answer as 7 kilonewton. So, 7 kilonewton is the net effect of all the 4 forces acting on the body, now which is going to act along the fourth quadrant. Now, what angle it is going to act in the fourth quadrant, that can be found out using the formula tan alpha is equal to sigma v divided by sigma h. So, tan inverse of, we substitute the values of sigma v and sigma h and we get the answer as 76.83. So, the final figure, as you can see, the force, resultant force is 7 kilonewton acting in the fourth quadrant, making an angle of 76.83 degrees. So, likewise, how many ever forces are given in a 2D space, all that can be resolved into the horizontal and vertical components and combined together to find out the resultant, and we can find out at which direction the object is going to move. Let us conclude today's session. We will come up with more topics and lectures on resolving of forces in 3-dimensional space. Till then, happy learning and thank you.